Welcome to lesson 2 of 2 in this tutorial, covering electric fields. This is the final video in our series of 2 lessons on the topic of static electricity. Here are the key learning objectives for this tutorial. We'll be looking at electric fields and how to draw their patterns. Here are the AQA specification points for this tutorial. Feel free to pause the video now and have a quick read through them before we begin. The first point we will cover looks at the production of an electric field. If an object is electrically charged, it will create an electric field around itself. An electric field is very similar to a magnetic field, but instead of a magnet at the centre of the field, we will have a charged particle. Now, we'll look at explaining electric fields. As we can see in this diagram, the strength of the electric field varies from strong to weak. The field strength will vary depending on the distance from the object. As you get further away from the object, the field strength gets weaker. Similarly, the closer you get to an object, the stronger the field strength will be. Our next learning objective covers how to work out the force between charged objects. Here, we can see 2 objects in electric fields. Force strength will vary with the distance of objects in an electric field. As the 2 objects get closer together, the force between them will get stronger. Similarly, as 2 objects get further away from each other, the force between them will get weaker. Here, we can see particle A, which is positive, and particle B, which is negative. The electrical field of A will interact with the electrical field of B. This causes forces to act on both A and B, moving them closer together. Here are 2 shared objects with their respective electrical fields. Charged objects experience a force in an electrical field. If we place one object into another object's electrical field, then the force could be attractive or repulsive, as discussed in the previous section. You should be able to explain how an electrical field can lead to the production of a force, whether it's attractive or repulsive. This is a very important concept to understand. Now, we will look at the non-contact force between charged objects. Electric fields can cause sparking. Similar to charge difference, the larger the charge difference is, the stronger the electric field will be. The stronger electric field means that electrons from air particles will be removed. By removing the electrons, the air will become much more conductive. This means it allows a current to flow through it easily, leading to the production of a spark. Our final specification point will look at drawing electric field patterns for isolated charged spheres. Here's a step-by-step explanation of how a spark is produced. The larger the charge difference, the stronger the electric field will be. This will lead to electrons being removed from the air particles, so the air will become more conductive. Since the air is more conductive, the current will flow through it more easily, causing a spark. For AQA exams, we need to be able to draw the electric field pattern for an isolated charged sphere. There are a few important rules to remember. First, the field lines must be drawn as straight lines from the charged particle. They will always point from positive to negative. And the sphere itself will either have a positive or negative charge. As you can see here, a positively charged sphere has the field lines pointing away from it, whilst the negatively charged sphere has the field lines pointing towards it. As we get closer to the centre of the object, the field lines start getting closer together due to the circular nature of the sphere. Therefore, the electric field strength is stronger. We've now covered all the learning objectives for this lesson. Feel free to skip back through the video and re-watch any of the sections you are unsure about. We have now completed Lesson 2.